Well, good morning, everybody. Let's get into just a quick discussion about the setup and the weather pattern this week. We have our first system that's moving through parts of the Great Lakes today, and it's got this wintry mix with it in parts of Minnesota, Wisconsin, getting into this part of Michigan. It will slide over into the Northeast, which is where we do have the winter weather advisories. Again, there's a lot of fog in the setup right now. We've seen some pretty wild daily temperature swings with the moisture that's coming into the atmosphere with each day as it kind of warms up. We're saturating it, then the temperatures drop off at night, and that gives us this these dense fog layers, which we've seen just dotted throughout much of the eastern two-thirds of the country. We're then going to watch later on this week for a pair of lows. There's going to be one that ejects first and then a second one that follows it. This will be like Friday, Saturday timing coming through here, and we will be needing to discuss the risk of some stronger storms with that as well. Including the chance of snow on the backside. And in the Northwest, we still have the winter storm warnings that are out for parts of the Cascades. You can see them over here in the Northern Rockies. And again, another day of strong winds coming off of the Rocky Mountains into parts of Montana and also around Utah. All right, let's just get a quick look at this because I want to dig into something a bit deeper the later we go into this forecast video. This is the radar imagery right now. So we can kind of see our two systems in the west, one that came into California there, spreading more heavy rain, kind of coming through the Bay Area up towards Sacramento. And you can see right here, this next frontal boundary sneaking through parts of Washington. The low that's kind of sneaking its way through parts of the Great Lakes, right in through here. We're just keeping an eye out to see if any of this is turning over to freezing rain this morning. I did look at all the OBS, and I did notice there was multiple OBS of freezing rain in parts of southern Wisconsin early this morning. And if we watch this system move farther to the east, we're going to look at the snow chances it'll produce in parts of the Northeast. Just having a look at the radar data, this is on just agweather.com, we can see that the precipitation type algorithm has gone over to that pink representing freezing rain in this area. And that kind of lines up with some of the service observations. So I just want you to be aware that's what we're dealing with early this morning. Now, the big story in this forecast video is going to be about what I put in the feed last night. I want to talk about what the chances of this La Niña transitioning quickly to El Niño might mean, and we're going to look at a lot of analog years. That's what all of this is going to be. So if you just want to get to it, slide over to where I get about right here, and we'll start to cover that. But in the meantime, we're still back on this narrative. And the important thing about the storm system moving through here is, yes, we're going to be putting in some more precipitation into some drier regions we've seen since the beginning of December. But it's these next two lows that I'm most interested in to see how much precipitation they could revive across some of these driest places in the country. And we also need to see that going forward, we're probably going to give a drier signal overall to the west as a ridge begins to develop there. Again, the narrative yesterday is starting to carry through nicely into what we're talking about today. Now, I just showed you a map that goes back to December 1st, but if we go back even farther than that, a 60-day precipitation map that shows you the percent of normal, it's just to stress how dry things have been across parts of the south central United States, as you can see here, and then getting over into the southeast. So what we're watching most carefully is a pair of waves. Now here's the first one right in through here. In fact, there's two. You can almost see like two areas of vorticity right in through here and in through here. And then we're going to keep an eye on how this precedes what's coming through parts of the North Pacific right now. I'll just kind of show you how they link up in a moment. Now overall, we do have some sense of west or even southwest flow, but it's so dry because of the orientation of this flow in the jet stream. So we're really, when we see the flow coming almost directly out of the west during this time of year, we kind of amplify the effect of the rain shadow coming off the Rockies, which is why we've seen such dry conditions. What we need is, you can almost see the trough in here. It's got this strong positive tilt, so it's like a forward slash. It's leaning toward the right. What needs to happen is a trough like this one or this one needs to come over New Mexico or Colorado and have negative tilt to it like that. Now that would bring in true southwest flow. Instead of having a ridge over parts of the Gulf, the ridge would be somewhere over here. The net effect would be to open that moisture source up, and we'd be looking at a big Colorado low or a Panhandle hooker or something just big enough to deliver moisture into these two areas. But as it stands, we're going to get a shot out of this. It's just not the most ideal. My biggest concern is when these lows form, how quickly they just run across the country, which we saw in yesterday's forecast. Now, as I mentioned, after such an incredibly wet finish to 2025 and start of 2026 for California, we are going to take a bit of a break. All right, now the Northwest still stays in the pattern with storm systems coming through, but we're going to take a bit of a break into California. And I'm going to be watching the potential of these next two storm systems to bring in moisture to some key areas that are very, very dry. Unfortunately, the risk of staying drier stays alive in this area that I'm shading here, getting up in the Canadian Prairie. And once again, we've watched the forecast to kind of not dig these systems far enough into the southeast to deliver moisture to Florida, parts of southern Georgia, coastal parts of North and South Carolina, all the way up here to parts of Virginia as well. And that's just been a consequence of the way this pattern has been set up. We're just not driving systems here. Now, there's some hope 10 days from now that we put a trough down here. But even with that, the models are not picking up on a signal of delivering wet conditions into that area. Where they are finding the wettest conditions, well, here's the latest European model forecast for the next 7 days, looking at the probability of over an inch. And as I look at this, you start to see this region in through here that is drier. And one of the big reasons for that is that this is the dry slot on the backside of the storm system. So there's snow to the north of it, and there's heavy rains, including some stronger storms to the south of it. But the greatest chances of the wettest conditions kind of split on the speed of these two systems coming through. So they're drawing dry air around the backside. It will come with the temperature change, of course. But that's your probability map for getting an inch out of this next couple of systems over the next 7 days. Now, if we step this down to half of an inch, all right, this is what the map looks like, the probability of getting half an inch. And you'll just start to notice how far back into the west this doesn't make it. In other words, this is not starting up a system in north central Texas or even south central Texas. The system is progressing and developing further downstream. And that's all because of the tilt. If you could get one of these things to tilt negatively, then it would slow down and rip straight in through like this, and all of a sudden we start talking about just pulling moisture back and curling it around. But this system's got a forward tilt on it. It's going to move quickly and progress through the pattern, and as a result, our risk of staying on the drier side of average is here. So this is the chance now of staying under a half of an inch over the next 7 days. And here's the chance of staying under a tenth of an inch. So you can see the effect of not having storm systems roll through the Canadian Prairie. No clippers are going on after the current one moves through. We've got to wait several days for one of those to return. I told you parts of the Southwest gets a bit of a break, but the fact of the matter is, even though this system's going to try to emerge here, it's not going to develop until later. And as a result, we're going to leave a lot of Texas out of this particular setup. Also note the trajectory of the system coming up toward, Ontario and Quebec is going to keep a lot of the southeast drier by not driving a big front through that area to bring in the precipitation. Okay, so where is it? It's this right here, and it's these 1, 2. Ready? So if I play the vorticity map forward, all right, you can see where these waves are. So here's the lead wave. You'll see the two behind it, 1 and 2, and that lead wave comes through on Thursday and goes right through Wisconsin, and then you have your second wave here, dipping down. And there's a lot about this I love. But do you see the problem? That trough is ahead of this trough. You need kicker waves. We talk about that all the time. We want this wave on the back side of it. But this ridge building in is not going to let that happen. You see, if that wave was on the back side, let's just draw over and say it was here. This lead wave wouldn't just go like that. It would get ripped north, and we get that slowing down of the pattern which we're trying to get. Instead, look who wins. It's the northerly wave. Friday into Saturday and Sunday, and it just digs into the northeast. So they don't work together to give us this, this system that we're hoping to see. Now, I mentioned there is going to be the risk as this comes through of some severe weather. I just want to show you this real quick. Take note that not today, but tomorrow, okay, on Wednesday, we're going to keep an eye on this area for some stronger storms. And then we get out here into the day on, that's Wednesday, this is Thursday. This area starts to open up with more of a chance of having those stronger storms. The SPC yesterday afternoon, let's just go have a look at their latest map. Yeah, they did include a lot of the delta down here. Sorry, let's hover over it. There we go. For 15% chance of having those strong to severe storms. I will be watching carefully to see how much farther to the north this may be edges, but right now we're just going to stick with the SPC analysis on where those stronger storms could possibly be. All right, let's do a little bit of model comparison. I haven't shown you this in a while. Lately, throughout much of the end of December and early January, the ECMWF has had about a 4% advantage on its skill score at mapping out the 500 millibar height pattern. We look at that quite a bit. And but lately there's been a pretty big separation just here in the last few runs. I think we just need to take note of that when we compare the models. All right, so let's finally get into some model data here. Okay, so we're keeping an eye on this today. Okay, and that moves into the northeast. There you go. Look at the European over here, while our next wave moves into, again, the Pacific Northwest. So this is why the winter storm warnings are out here, expecting those strong winds coming off downslope in Montana, but bigger snows. And it's actually in both models, pretty well resolved. What's interesting is the lead wave, there it is, coming through Arizona and New Mexico, all right, with the snows still throughout much of the Intermountain West. The lead wave is pretty well timed in both models. Okay, I could say the GFS is a little behind. Okay, see the GFS versus the European. But overall, I have to say that's pretty good agreement. Now, what's not agreed upon is the total precipitation amounts. So while you see the big green blobs in the same spot, again, this is Thursday through Friday morning, all right, it's not this super consistent look, all right? I'll show you that in a minute. All right, so that system rolls through. Looks like some very heavy snow coming through possibly through parts of Wisconsin. Right up here where Huron, Michigan, and Superior come together, getting into parts of Ontario, some very heavy snow. And then it exits east. Now we have the follow wave, all right? Now remember, there's three pieces to this. This is the lead wave. Then you have your next wave, which is out ahead, and then your follow wave, which is on the backside. Man, I needed this guy to be back here to kick this wave, but it's not. So what you end up getting is this snow chances from New Mexico, southern Colorado, or southeastern Colorado, through Kansas, maybe clipping parts of Missouri, Nebraska, Iowa, Wisconsin. And that's where the models are taking it. And again, we're going to watch out for the stronger storms on Friday here. Thursday, it's a broader area in this region. But then that system rolls through, and you'll take note. Like, we have another weak system coming into the northwest, but California gets a little bit of a break for a while as high pressure builds off the California coast. And that takes us all the way out there to day 10. Now, day 10, this is critical. The models are trying to drop a trough of low pressure here, and the GFS is using it, like just ripping a system up the coast. And yeah, look at that. All right. Not in the Euro, but I'm going to show you some week 2 forecast stuff in a minute to look for any chance of this happening, or if the GFS 0Z run is kind of an outlier. Okay. From there, I don't remember why I opened this page. Let's see what I got next. There we go. Total precipitation. This is the European model forecast for the next 7 days. And as I mentioned a minute ago, model differences are pretty stark on precip. The Euro is a wetter forecast. Can you see that? That's the Euro. That's the GFS. Sorry, Euro GFS. And you can compare this to the NBM, all the AI models that we're using right now. But this is the general setup. And you can see in both cases that there is a dry slot in through here that we cannot ignore. Again, it's right in through there in the Euro. So it does appear that the best chances for the wettest conditions are going to be coming out of eastern Arkansas to western Tennessee, Kentucky, hitting Mississippi, which desperately needs the moisture. So does northern Alabama. And a lot of Tennessee, Kentucky need this moisture. Again, you can find these drier spots pretty easily out of this comparison. On the snow side of it, there we go. New European model did back off on snowfall totals through here. We're picking up 3 or 4 inches there. Heaviest snows coming out of southeast Colorado. We need as much as we can get into the Colorado Rockies out of this, but we're talking 40 plus inches of snow in the northern Cascades and a good foot to foot and a half in parts of the northern Rockies out of this. Then as both of these systems combine, okay, in their total snowfall, take a look at that area again. I told you, right in through here, getting into Ontario and then continuing through Quebec. Pretty good snows, and some deep into the interior of the Northeast as well. This is the GFS. It is trying to keep this together a bit more. Can you see that? In the total snowfall through this area. And it's good because it'll melt. We're going to have a warm up after this, so that'd be kind of nice to get some moisture in and then just melt it right back off into the ground. Probability-wise, this is the chance of getting an inch. So I just want to point out that the European ensemble, it's not overly aggressive on kind of bridging this area with heavy snows. If we step it up, here's the chance at 3 inches through the next week. Then I can see this pretty light or small risk in through here. Heavier down here into parts of Colorado, maybe Kansas, maybe the Panhandles, and then as you work your way into the Great Lakes. 6 inches, now you can find your main corridors here, possibly here, and then we're, of course, going to watch these western mountains, all right? Okay, winds, just need to mention this because I want to continue to pay attention to how strong these winds are coming off the mountains here in Montana and parts of Wyoming. You can also see in kind of the Columbia Plateau and the basin here as well, some stronger winds. But just watch this system Thursday into Friday deliver 30, 40 mile an hour gusts in this area. So I'm quite pleased that my son cleaned up we have a pin oak in the front yard and it drops leaves all year long. It's kind of annoying. I love the tree, but it's kind of annoying. He cleaned them all up for me though on New Year's Eve. It was nice for him to do that. And then my neighbor went out and cleaned his leaves up yesterday. So, hey, my yard will look all right. Anyway, sorry, stronger winds coming through here. All right. Okay, the pattern. Day 10, that's the time we're looking at. Models are attempting to drop something here. And I'm going to watch it carefully. This is January 15th. I'm going to watch this carefully to see if something might roll up the East Coast at that time. But currently, if you look, here's all 4 of the models I like to compare. We're going to add the GFSAI here soon, and some other models too as they're coming out. They are drier west. That's been a pretty consistent signal. Big ridge builds in. That makes sense. But they've backed off a bit in the CPC outlook on how dry this is. All right. And they're trying to return a clipper track to this. Can you see it? But I'm asking, where's the system that could be here if that trough develops? Is it too far east? That may be the case. We're getting too much dry air on the backside of it. Okay, temperature-wise, again, here's today's highs. Very hot for this time of year. All right, going to tomorrow. Look at this, 60s right here in parts of Missouri, Kansas, excuse me, Nebraska, Iowa, even high 50s in Illinois. There you go, pushing east on Thursday into Friday. Look how warm it is in India on Friday. But then again, when does our snow start? You can start to see that cooler air coming into this region as the second wave comes out. And we're going to hover right around that freezing line to give us the chances for snow in through this corridor. That's Saturday. Here's Sunday into Monday, so your cold air passes through, but the mild air returns. That's why I said that snow is going to melt. But we made a case yesterday that I think we could set that Arctic corridor back up, just going to be later in January. And some of the new model forecasts are beginning to show that, and I'm going to make a case for it, and then I'm going to get into all this long range. All of this is long range for you, all right? So here's the next 5 days. That is day 5 through 10. So stockpiling warm air here, what's all confined to Alaska and the Bering Sea. But watch from mid-January. This is valid from the 11th through the 16th, okay? Watch as we go from the 16th beyond. Watch that erode so quickly. And this begins to show up. I think that's what we're going to be watching in that 3rd week of January. Now, to give a little bit of help to this, I'm going to use the Bureau of Meteorology out of Australia's forecast of the MJO because they're trying to take this out of null space and pass it through phases 6 and phase 7 with a bit more amplitude than some other models are doing. And what we know is a transition from 6 to 7 takes the trough out of Alaska, begins to establish it here. Yeah, there's a lot of ridging setting up on the west coast, which we are seeing in the forecast. You just saw it a moment ago. But by the time you get from phase 6 in January to phase 7, that ridge becomes very well established. There's a kind of a Aleutian Islands North Pacific trough, and then this comes back. So that's flow doing this. And we're starting to see some of the effects of that in the European model. So here's week 2, but as I add in week 3, do you see it returning, the cold in the forecast? And that's what we think might happen by mid-January. Now, could that evolve? Yeah, it could evolve. It all depends on the proximity of this, honestly, because I don't feel like the North Atlantic is a major player today, right now in the forecast. I think it's still the North Pacific. But that's what I'll be watching. All right, that keep a close eye on this. By the way, the CPC does agree with that. If you look at their forecast for week 3, week 4, which is the last 2 weeks of January, they've got that return of colder air with the ridge in the west bringing in more warmth and a drier run of it. And with clippers, they're kind of hitting 2 tracks. The big issue here is this is not the right setup. This is all wrong, okay? If you're trying to get southwest jet stream flow, because high pressure here has got flow like that, and low pressure has got flow like this, and nothing's coming from Hawaii to Oklahoma, and that's what we want if we're going to just rip this whole thing apart. But that's what you get when there's an El Nino. All right, so are we going to get an El Nino at any time? Well, if you look back over the last 90 days at our ocean temperatures, we can see that I would call this an isolated La Nina, and here's why I'm saying that. Our biggest, baddest La Ninas have been cold here and cold all the way up into the Baja of California and cold all the way around, and then they're also cold way down to here. So like the big dogs, like 1998 as an example. This one's just been primarily focused in this area with this PDO signal showing up strongly in the statistics, but not so much in the ocean temperature pattern. So here we are going through December into January, and we're just curious how long this thing is going to last. So I want to show you, again, I showed you this on my last video of 2025. If you go from the South American side over to the Indonesian side of the Pacific Ocean, running along the equator at the top of the ocean, and you look down, we continue to see the edging of this warmer water. See it with time here in December, moving its way back up, eroding the cooler water signal here, which this is just another way by which we see the warm water sloshing back. And when it emerges, it'll emerge quickly, and the trade winds, which are already responding by slowing down, will allow it. Okay, we talked about that yesterday. The trade winds are expected to lose their strong easterly component. So I mentioned this yesterday, but now we've got a better than 90% chance. Just looking at the European model, that's all we're doing. The European model is suggesting, sorry, this should be, I need to update this. This is the January 2026 seasonal update. This isn't the, see, it's up here. But by May and June, we've got 90% of the ensemble members in El Nino territory, which is above half degree. Now, the importance of that is to see how the forecasts respond. Mid-month, we're going to get an update from the CPC. This is their current outlook for the way that January, February, March are going to look. And it should look like this, because if we look historically, January, February, March, okay, has these negative anomalies here and here with ENSO. That means if there's a La Nina, this is wet, and this whole region is drier. That's the risk. Okay, so it's not, don't paint this like black and white, wet, dry. It's just it's tilting the odds in favor of being wetter through the Ohio Valley, wetter here, and drier in these areas. So yeah, their forecast mimics that perfectly, doesn't it? Okay. On the temperature side of it, let's flip this over from precipitation to temperature. What we tend to get, now you're going to have to flip the colors in your brain here, but where it's red, we tend to be colder than average, and where it's blue, we tend to be warmer, because these are correlation maps. These are not anomaly maps. So we would expect their forecast to do this. All right. Now, what can we add to it? Well, if I look purely at precipitation next from the European model, their January through March outlook looks like this. And if you take note, it's drier southeast, drier central plains, but it's wetter in between. Now, I'm curious if this whole wet bias in the model, not bias, but this wet anomaly in the model is because when it was initialized, it was storming like mad in California. We would actually expect it to look more like this. Now, this is the April to June. And as I mentioned yesterday, the April to June forecast has got this just massive wet corridor in the midsection of the country. And I told you, take this with a pretty sizable grain of salt. And I would like to add to that to make a bit of a case for why I told you to do that. Now, the April to June correlations with El Nino conditions. All right, so I've labeled it so it's clearer now. The correlation map, again, for going into El Nino by April to June, the reds are wetter and the blues are drier. Okay, and overall, if you look at it, it actually tends to suggest we're wetter here. We're even wetter in the west, but drier north. And that could be an interesting setup. I mean, it really could. All I'll be watching is how far back to the west do we get these big storms this summer? Is Kansas, eastern Colorado, Oklahoma, and Texas the target? Maybe Nebraska the target for storm chasers? Or is it the Delta, which is very hard to chase because of the road network and the trees? Or are we going to be watching a southeast setup? That's just questions we're going to ask. What about when you get into summer? Summer tends to give us that corridor with a lot of storms, and we tend to get hot and dry in Texas. Actually, the Cotton Belt tends to get hot and dry by July through September. Hotter and drier than normal. Now, these correlations, you just have to be careful. These correlations down here are like 0.2 to 0.3, negative 0.2 to 0.3. So it's a shotgun blast on the scatter plot. It's not a 1-to-1, which is why we have to remember that La Nina and El Nino's greatest influence is always during winter. The correlations are strongest during winter. But this is when you look at just a multivariate INSO index and look at these particular ranges of months going back to basically 1979 to 2024. All right, what are my analogs? This is what December 2025 height pattern looked like. So I went looking for ones that look similar to this, and I found several, but there's a few that just stick in my head. One is December 2017. So again, here's 2025, there's 17. You're going, what? Why is this one there? Well, it's there because of this and the ridging we saw here. It's not a good match. It's not a perfect match, which means January 2018 shouldn't be high on the analog list, but it's one that I'm looking at. Now, let's go back to December 2025 and compare it to 2008. Now, 2008 has much more of a flavor of 2025. See it? That's 2025. There's 2008. A lot of similarities overall, including the Scandi Ridge, where this cold air is here. I mean, just have a look. See it? So I like 2008 into 2009. And then the last one we have to talk about is 2013. Now, 2013 was a rare and special bird here, okay, because of the linking with, especially in 2014, to the stratospheric polar vortex, just dropping lobes of Arctic air into this part of the country. But what did we have? We had a displaced Bermuda high, huge ridging that set up here in December 13. And, we can make an argument that 13 needs to be considered. So what do we do with all of this? Well, January, February, March of 18, 09, and 14. So remember what I did here. I got to add a year to this so you can see why I'm doing that. So we get to the next year. They were wetter here, wetter there, maybe wetter here. And look at this. Kind of drier, the way that typical fading La Nina winters are. So I want you to understand that what you're looking at here is speculative. Don't look at this and go, hey, Snodgrass, you got to look at these years. These are the top. No. I firmly believe, I love analog analysis, I do, but I firmly believe that based off a study that a colleague of mine did, his name's Ryan Shriver, Dr. Ryan Shriver, he said, he goes, when you look historically at analogs, any year, how often does a previous year match a current year? And it is incredibly rare to find high resemblance. You can match patterns, but the resemblance down at especially at the local level is difficult. It's almost impossible. So I have to trust his research. What happened January to March in temperatures? Well, guess what? We opened this back up to colder air. And they're going, holy crap, that's dark blue. Well, I set the minimum to a 3-degree anomaly. So I just needed to see the contrast in the map. So don't just understand that we tended to open this up to rounds of Arctic air. And yeah, 2014 is biasing this just a lot. What about beyond that? April to June. Interestingly enough, a lot of the southeast up the East Coast was wet. We were wetter in through here. Drier where it's quite dry right now. That's the composite. I'm going to show it to you just so you can see it. And look at the west. Now, once we get past May, we expect the west to be dry, except for those summer thunderstorms that can hit when the monsoon sets up later. Now, there you go. And the June to September, when you look at these years, was very wet. And I don't know what Missouri was doing wrong here, Kansas City, but around it, very wet. Dry in the southeast, drier north, Red River Valley, dry in the northwest. Now, if I live in Illinois, so wherever you live, you tend to remember specific years. And if you're going to tell me that it's 18, 9, and 14 are the summers I'm looking at, I mean, I remember 9 very, very well. My daughter was born in 9. And I took my wife to the hospital, and it was 70 degrees outside on July the 16th when she was born. And that's because that whole summer, we just couldn't get sustained warm air. It was all west. 18, that's another huge year for the Corn Belt. 14? 14 was, I remember I walked into the offices of ADM over in Decatur with my first company I ever started and told those guys I could do yield prediction. Boy, I got laughed out of the room because my model was a bit off, but whatever. It was cold, and I'll never forget it, driving over there and it was being so chilly. But that's something to think about here. Now, those are my years that I've just picked out lately. And 3 is not enough. So what if we went back and looked at the entire sequence of El Nino, La Nina events since 1950 and only looked at emerging El Niños out of La Nina. So I'm not going to pick these years where there was inso-neutral conditions in winter and then it became El Nino. I want to go from the ones where it was down low and came up high. Okay, that's it. Because that's what I think we're going to be seeing here. So here they all are in December. Those are the years I'm going to choose. I'm going to go back to 1960 for my analysis. And guess what they had? They had this, which we had, and December had this cold setup, right? I mean, that there is some similarity to the years that emerged with emerging El Niños from La Niñas to what we just saw in December. So here you go. January through March, what did they look like? Well, it's pretty cookie cutter La Nina. We were wetter here, wetter there, wetter here, and drier south of that line. So that's not a good signal for this area. What about the April to June? Now, when you look at this, you have to remember a couple of things. I've got 2023 in here. That's the last time this happened. And in 2023, this whole area just didn't measure precipitation April to June. So there's a big fat zero going into the analysis here. But look at some of the other years. I mean, you got 18, 14, and 9. But I've also got 06 and 02. I got 1997, 94, 91 is in this as well, which is scorching hot summer. So was 2002 in the midsection of the country. Now, this is precip, but that is what spring looks like when you just stitch them all together. Okay, now again, we're just doing this analog analysis, and then here's what June to September look like. Now again, I've got these banner years. Oh, 2023, don't forget, it stormed like mad in here in June to September. Late June to September. But at the same time, I've got 91 in the mix. 76 is in there. 82. There's some years that are in this list that were very dry. So what's the point? The point is to tell you that once you get fully into summer, using big teleconnections like El Nino or La Nina often don't work. They work in winter. Well, they work better in winter, but in summer, you don't have the forcing. The jet stream's weak. It's way up northern Canada. So you can't rely on it to be this demarcation of wind structure in the atmosphere. And as a result, you get into a summer where it's all thunderstorm driven. And that's hard to predict. So I wanted to show you these just so we have a clue. And I actually don't remember what I left open over here. Oh, I went out and I wanted to show you the June to September. I lopped off everything before 1980 for this analysis because I wanted to compare it to the historical norms from 81 to 2010. And those particular June to Septembers were not hot here, most of them. Okay? 2002 and 91 were for here, but most of these were hotter west. The West remembers a lot of these hot years. And what did I have my last one up for? Oh, that was just, I was working on some other stuff. So that's what I'm going to present to you today. And we're going to build on this narrative. I hope Matt kind of picks this up and gives his analysis. I know Matt's been working hard on some MJO stuff too. We're just going to have to run with it. But just understand, we just started a narrative today. I didn't draw a line in the sand. That's all. All right? We'll talk again. I'll talk to you on Friday. Matt's got the next couple days. See you soon. Thanks.